the topic at hand for us that I will kick off now is actually about how we do rapid GraphQL API development using PostGraphile. Right? Quite a mouthful, but let's see how this goes. Yeah, so my name is Ruwan, and I currently work as a product architect for Axinom, and my main responsibilities would be like working with several of our teams where we develop some of the cool products right now that we are focusing on Axinom when it comes to media and OTT industries, building completely new microservices from scratch. This is something we have been doing for the past couple of years. We had some amazing stack before that, but we somehow changed our direction to go into a new vision, and that's what we have been doing. And I'm also part of this team that does this. So going forward, what I would say is just to give some context about what we are doing at Axinom, so you have some idea about what I'm going to talk later on. So I will not take too much time here and just list down some of the key areas or best things I can list down here. So we have quite a lot of milestones, but these are the three that I find are interesting. So the company actually started somewhere in 2001. This is where we initiated, and our main goal was content management. That was our main topic, a focus area, I would say. So here we were developing solutions for customers who would want to manage their content and deliver it to their clients, right? And so we had this CMS system developed called AxiMS by then, back then, and so that was quite popular. And then going forward, like almost 10 years forward, so here we realized that there are certain things like changing in the world, like people were using less of DVDs, less of CDs, and people were more into streaming content. So you have this Netflix, Hulu, HBO, and all of these streaming services were coming up, and people wanted to also now integrate the content management together with their media processing workflows. So here we also incorporated some other services into our offering, where we do this media processing, digital rights management, adaptive bitrate encoding. So all of these media related stuff we incorporated into our content management system. Right? So this was one of the major milestones for us. And then jumping several years again, almost a decade forward, here almost last year. So we have been focusing quite heavily on disrupting this space of content management, because a very common pattern that we were seeing with our customers were that like they were having this dilemma. You when you are investing your money on some kind of a system where you have like a monolithic system where you develop everything using that system and you invest heavily, sometime later you might have some problems, like when you want to customize, if you want to develop something on your own in-house, and if you try to integrate with that system, it becomes a little difficult because you have some incompatibilities maybe. So they struggle a little bit. How can we have this monolithic solution, or should we have a monolithic solution, or should we invest all of our efforts in building something of our own? So you have this dilemma between whether you should be buying something out there that's currently in offer, or should you invest all of that time building it using your own company efforts. So our solution to that, or our approach to this, is why not both, right? So if you can take certain parts out from some service or some managed services where you have some modular design, so things can be swapped out and in as needed, but also you still have the freedom of building things completely from scratch, right? So this is the current focus area where we are at. So Axinom Mosaic is our product offering, and this talk that I'm going to be doing, I'm kind of doing it as a case study based on this Axinom Mosaic product, right? So starting off, so what we identified is some of the services that we can offer to our customers are the ones that are highlighted here. Right? So there are some services that are super important, but also you don't want to spend all of your development efforts building from scratch. So here the focus is buy. So these are the things that you can just take as a service and connect to that. And for example, we have these things like admin service, so authentication and authorization. This is something that every single system or solution will definitely need. So we offer this as a offering in our portfolio of services where we follow the best practices in the industry, and you can just use it as a hosted software as a service. And we have these encoding services where you can encode your movies, videos into different formats and image formatting and all of that. And then on the other side of the spectrum, we also have these kind of services where you would have some interest on how to customize. You would care exactly how they are designed. Of course, what we do here is we have built some kind of a template where we offer some source code to our customers. We give them, okay, this is our opinion, our vision of how you can manage this content, this media content, this aero content or whatever. But because it's with source code, whoever is purchasing this will have the full ability to customize this completely. So here we need to think quite a lot about our strategy when we want to give out source code to make it easily comprehensible. So what we have built and also extensible. So this would be a very high level idea of what we are working on right now. And so now I will kind of move towards this customizable services because that's the interesting part. And there are some design choices that we have made when building these customizable services as templates so that our customers can just take them over into their own control and build them to the next level. So here, some design choices are, we have opted to use Node.js as our backend API or backend platform, and GraphQL as our API format. So it's kind of like REST, but you have much more features and capabilities when it comes to querying your data stores. So we like GraphQL quite a lot, and comparing with our past experience, this is also very apparent that when you are building these media related solutions, it's very often that you want to have very expressive APIs. So REST APIs don't really cut it for us. So here the choice was to use GraphQL, where you have very strict typing and it's very developer friendly. Like if you are using VS Code or whatever IDE, it will have plenty of extensions that helps you type code in a very efficient way with strict typing and so on. And another choice that we have made is to use PostgreSQL. And this one, it's one of the best open source DBMSs out there right now. It's competing with all the high heavy hitters like Oracle, MS SQL Server. And by the way, I'm not dissing any document database management system. It's just, again, coming back to our context, having a relational database management system makes the most sense for us because that's how we design our entities. Where, for example, what you're seeing right now when it comes to managing some movie metadata, we have movies, actors, TV shows, seasons, episodes, all are related to one another via some keys, foreign keys, and you want to have some consistency between these entities. So it makes more sense for us to use the database management system, which is relational. So that is one choice that we have made. And finally, another design choice here is front end. So we have opted for using React for our front ends. And by the way, there are many talks talking about micro front ends. And this is also an area that we heavily focus on to have all of our services coming with their own front ends. So you can really work on one service without affecting all the others, and they are orchestrated in a single application. But you don't have to worry about like having competing controls or whatever. So your service is having all isolated components when it comes to the React frontends. So yes, so these are some of the design choices. And having this in place, I would like to move on to the next points here, mainly talking about the challenges that we had. There were quite many challenges that we had, but I'm focusing on one very narrow area, which is the services backend APIs, and how we wanted to develop these APIs for our microservices and also give out the source code to our customers so they can now take it further. So we want to make it as easy as possible for them to come to market or release to market with their changes without being stuck too much with very repetitive things. No? So having this idea, so we did some research and came up with some philosophy that we want to proceed with to have this rapid application development for our APIs. So one thing that we really wanted to focus is to have this database as an API. So we want to embrace this concept of having our database directly exposed out as an API without having too much logic in between the consumer and the real storage. Another fact that we wanted to focus was on auto generation. So we wanted to have as much auto generation as possible so the developers don't spend too much time and waste time on writing like their repetitive code over and over. To use templates or plugins or whatever, we can use them to generate code based on some schema or model. That would be the preferred approach for us. And then last but not least, we wanted to have very performant APIs where the developer would not need to focus too much on making the API performant if we can make it already the default choice, right? So here we want to kind of work together with the auto generation. So the template can be used to create and generate very performant APIs. But we still want to leave out some space for the developers. So if they want to like make it extra performant or optimize it further, of course, that freedom is there. But as the starting point itself, we want to have quite performant APIs. Right. So with all of that ideologies in mind, with our rapid application development philosophy, we come to the elephant in the room, ultimately, PostGraphile. So this is the topic that I want to focus on because this library, this I would not call it framework. Yeah, it's a library. So this actually helps us to align with our design philosophies. And here I would see what we have to talk about next. So talking about PostGraphile, so this is, like I said, it's an npm package. You can install this using npm, install whatever package manager that you're using. And this example I'm showing, it's the CLI version. So you can just run it on the CLI without having to install it as a library, which is, of course, the other format of using it. So using it in the CLI form, it's good, but you will not get the full capability of the PostGraphile library. So for example, if I run the first statement here, all it's doing is it's connecting to my Postgre database, making a database connection. It will reflect on the schema that is deployed already on that database. So here I have selected this database called Media Service DB, and it will spit out or generate the GraphQL schema against that database. But the amount of flexibility that you have with this kind of a CLI based thing, it's less, of course, compared to the library format. So with the library format, they also offer you a nice HTTP middleware. So here you can use the HTTP middleware in your Node.js code, use it as a Express library, or because they offer different forms of using this, like Restify, Fastify. You have different HTTP implementations, and you can plug in these different formats. And here the example I'm showing is using Express.js, for example. And doing it this way, you get much more control over what this API will get generated. Right. So And having that introduction about PostGraphile, I would again touch back to our philosophies on to see how PostGraphile actually aligns with them, right? So the database as an API. This is something that we really like to do, but before I show that, the more common approach when it comes to developing your GraphQL server implementations, you have two kinds. The first one being the schema first design. So you start off by writing a very nice contract. Now you have a schema definition language in GraphQL specification where you define exactly what is the types that you want people to interact with. So here I'm taking the movie actor media example again, and if I am writing it in the schema first approach, I would have, for example, this kind of a schema where the movie can have ID, title, description, so on, and you can have some actors and whatever. Some relations can also be made. And if you have the schema defined, then you can configure some GraphQL server with the schema, and you can feed your resolvers separately. So you have a fully decoupled approach where you keep the schema separate from your GraphQL resolvers. But of course, that means you will have to code that GraphQL resolver and or resolvers and feed it into the GraphQL server implementation, which spins up your API. The alternative to this, which is also fairly popular, is to do code first design, right? So rather than starting off with your schema, you rather use some library that provides you the code first, but also together with schema. So you don't really decouple the schema out. You rather have it in code. For example, here you can see the library that I'm using. This is GraphQL library that I'm sharing here. It offers some native language abstractions like enum type or object type. So these types are coming from that library, and it will ultimately generate the GraphQL schema based on this abstraction. But the point is, you don't start by writing SDL directly. You start off by writing TypeScript or whatever your native language is. So here I'm focusing on Node.js and JavaScript, so TypeScript is my example. And then you would define the types of your schema along with the resolver. So you can see this example here. I have a field called actors, and the implementation of this field actors would be resolved through this function ctx.getMovie, and we pass the ID and then get the actors of that movie. So here you have a very tight coupling of the resolver together with the schema. Of course, you can think about refactoring the code here. The resolver does not need to be in the same file. It can be refactored out, but yeah, for clarity, I have it in the same place. And so these are the main two forms of implementing GraphQL servers. But then what PostGraphile actually offers you is the third kind, which is database first design, wherein you don't really write any GraphQL schema, nor you write any resolvers by default. You can write resolvers, but not necessary. So the single source of truth would be your SQL. So that is something that anyway you do. If you're developing some microservice, anyway you would start off by writing some schema. And here, because we are focusing again on relational database schema, my examples are based on Postgres. So here I would have some types defined for enums on Postgres, and I would have some tables for my data persistence for movies, actors, and movie actor, which is a many-to-many relation that I have here. So this would be the single source of truth. And if I start up my PostGraphile library or use the CLI or the library and point it to this database schema, it would be able to introspect and reflect upon this database schema and on the fly generate the corresponding GraphQL schema. So this is the whole point that I'm talking about here, how we will use the database as an API. So this is not true or not relevant for every single service out there. This is something I must say because it depends on your context. I'm not saying that this is the only way to do things and this is the right way to do things. It's just the way that's appropriate for our context. Because when it again comes to the media OTT context, most of our APIs are CRUD based. So about, I would say, 70 to 80% of the GraphQL schema and the API, it's just simple create, read, update, delete. And then maybe you will have some 20 to 30% of complex logic where you have validation, some publishing logic, and all of that. So for our context, it makes perfect sense to have this database as an API. But of course, there will be other competing arguments to this, because depending on your context, you might want to have some intermediate layer where you actually don't expose your database directly. Yeah. Right. So the next point I would like to move on to is about favoring auto generation, right? So this one, it's one of our design ideologies, philosophies that we really wanted to have, and how PostGraphile helps us exactly with this is by giving us these features. Now, so you don't need to write a single line of code for your resolvers if it is to do with CRUD operations. And if you want to have some computed fields, maybe like a summation total, maybe calling some function, so all of these can still be DB driven. So you can write such functions on the database, and PostGraphile will again reflect on those functions and add corresponding fields to your GraphQL schema. So you don't still need to touch your API resolver code. It can be DB driven. And this also offers you a very extensive plugin framework. They have built this whole library on top of plugins. So most of the auto generation that you get is based off of plugins, and you have a very nice community that has developed their own plugins and are shared in open source that you can use. And also there is the opportunity for you to write custom plugins as well. So for example, if you take the same movie table that we were looking at, if you want to develop a very expressive GraphQL API, you could use this plugin that's built by the community called this connection filter plugin, and it will immediately give you a very nice expressive API. For example, this is I'm just focusing on the filtering options here. So none of this is coded, right? You get all of this auto-generated. You just have the table schema, and you just fire up PostGraphile, including this plugin, and it gives you options to do these kind of between conditions. You can have date ranges, you can have logical operators where you have in, not, and conditions. You can have case sensitive searches. So all of this, it's free, free code that gets generated for you without your developers having to put their hard earned time into writing this kind of repeated code. And it's very consistent. So you will have exactly the same GraphQL schema across all the entities in your database. And such APIs would allow you to, for example, write this type of GraphQL queries that can be now used in your front ends to make them very rich, where you can query quite a lot of data with complex conditions to give exactly what the users need, right? And going forward, if you still don't like or are not satisfied with these default generated code, you can of course write custom plugins now. So you can use PostGraphile to write and extend your schema. For example, if I take this extend schema plugin option, so here what I'm showing is how the existing movies GraphQL schema can be extended to have this kind of IMDb rating, for example. Maybe you have your movies stored in your database, but you want to have some IMDb rating now coming from an external service, some third-party service. So here it's super simple. What you would do is you would write your plugin by calling this extend schema plugin, and we are using the GraphQL syntax here, extend type movie, and introducing a new field, IMDb rating, which is a float. And This right-hand side is some annotation. I could call it PostGraphile magic here, and it's all documented. So what I'm saying is, what we are saying in the screenshot is like, if some consumer wants to query IMDb rating, please always include the title, so that we can use that title to call the IMDb API and get the rating back. So this is some PostGraphile magic that is annotated here, but on the resolver side, then it's rather simple. Because the title is guaranteed to be included in the SQL query, you can actually use the value of the title in your GraphQL extended resolver. And using the title, I can call some function, get IMDb rating from movie title. This can be another REST API, it can be another GraphQL API, whatever, right? So just abstracting that part out. Yeah, so this is how you can easily extend your schema. And if you want to have some kind of a wrapper, so this form of wrapping, it's very nice when you want to do some kind of a custom logic before or after the auto-generated logic. So you have like a function override, basically, I would say. The PostGraphile library gives you a ton of resolvers, and you can wrap all of these resolvers with your own custom logic. And it comes in handy in very many cases. Like, for example, if you want to do user authentication and user authorization, you can wrap the existing resolvers using just one plugin, and you can check whether the current user who is invoking this has a, I don't know, authorization to call this token, or if it's even authenticated or whatever. So it's very modular. If you notice this pattern, you can have the authentication handled completely outside of PostGraphile, and you just have a wrapper that plugs in into all of the resolvers. And the example I'm showing in the screenshot is actually about logging. So that's another angle where we can have like some kind of a log being generated when before and after your resolver gets called. So here I'm just taking or writing to the console just before the actual resolver is called, GQL operation, la la la, and then after it's executed, take the result back and also logging that to the console, saying, okay, this was the output of your GQL. Yes, so this is the wrap resolver and process schema plugin. This is another a third kind. I don't have an example for that, but it can be used for situations when you want to stitch different schemas together. Maybe you have another third-party service and you want to stitch your GraphQL schema with that third-party schema. So you can write a plugin for that where you get the full control of the whole schema, and you can append and extend and create like a derived version of that schema and return that out, giving you more flexibility. And then the last point is about having performant APIs out of the box. So a very common question when people start developing GraphQL APIs and start to write resolvers is whether we should use an ORM or not. And before I answer that question, there is also a very common pattern and problem in GraphQL. I would say the N+1 problem. This is I would use this as the answer to the above question. So if you take a very seemingly innocent query, for example, like this now, so you have like a GraphQL query, you want to get all the TV shows with ID name, and for each TV show, I also want to get all the seasons with ID and title. Such a simple thing, right? But if you are using a custom resolver that you hand code using some kind of a ORM, you would think of a very naive implementation like this. So here would be one part, or the top part would be resolved using the first query, where you select all the TV shows with ID and name, get all that data, and then kind of loop or iterate for every TV show. We query all the seasons for that specific TV show ID. And this is super inefficient if you did notice that already. So the query execution time is data dependent. So if you have 100,000 TV shows, your query will be dependent on that number, of course, because you are looping it for that many times. And this would be a very naive implementation of it. But to address such implementations, there is also other libraries out there, other utilities out there to fix these issues by batching things together. So data loaders is exactly what this is. So using a data loader as a standalone library, so they are also very generic. They can be plugged into your existing resolvers. Basically, it kind of sits in between your resolver and the database. So when the resolver is making these inefficient n number of queries, it can intercept it and keep it in a batch request. So rather than sending it n times, the data loader can just send it one time, right? So it could be transformed into this kind of a query where you batch together all the TV show IDs into an in clause and then issue that in one go. So your round trip times reduce by n minus one times. So this would be one solution, right? But this is also common, but also thinking about this solution, this is not super efficient, but okay, it's not as bad as the previous one, but still it can be improved, right? Because now if you imagine the depth of the query increases, like you have TV shows, seasons, and under seasons I have episodes, and under episodes I have actors. So if you have 4 levels of depth, that means still the select statement count will increase as your query complexity grows. Of course, being with a relational database schema, working with a relational database like Postgres, you may question why not like just go for a join, because you already have the foreign keys. For example, you can just do a join between TV shows and seasons and just have one query, so it does not grow with your query complexity nor the data. So this is exactly what PostGraphile is doing. So it's not using ORM. Coming back to the first point, it is using some form of query building internally. So all of the resolvers that are auto-generated uses their own query builder format to generate these smart resolvers. So instead of having these two queries, you always end up with just one query like this, where you have a very nice join going on. And yeah, if you have the correct indexes in place, this would be super efficient. So the key is to have a sound database design. So this also touches back to the first point, to have the database as an API. So if we go in this direction, it's very important that you invest some time and effort to make your database schema as efficient as possible and as performant as possible by having the right indexes in place. Yes, so this was all I wanted to show you guys, but just as a quick demo, I wanted to also show you how this looks like in real life. If I can execute a quick demonstration. So what I have going here is the database I've already deployed. I just have, let me show that to you. So this is what we have, right? So we have actor, movie, and movie actor participating in a many-to-many relationship, and that's all I have. It's a very rudimentary database table structure with 3 entities, or 2 entities and 1 joiner. So if I fire up PostGraphile against this database, I could use the CLI format just for this one. Yeah, so by running this, what I'm doing is I'm connecting to my database, Media OTT database, running it in watch mode, and I'm enabling some plugins. So these 2 plugins I'm enabling, so I can show you guys how nice the API looks like. So if I take this one out, so this is the port that I'm running in. Yeah, so exactly, this is the output. And if I just write a very basic query in movies, if I go inside, and you can see already, like I did not write any code. So the only thing I'm running is just this. There is no code at all, but not necessarily you can extend this with plugins, like I said. This is what you get out of the box with the built-in plugins, and I can just query the ID. Oh, sorry. I can query the ID and title, publish date. Maybe that's enough for now. And if I run this, I can get this output on the right-hand side. So they also have this graphical interface that's built into PostGraphile, in case you were wondering how I got this interface. So when you start it up using the CLI, it spins up the API and also has this GUI, graphical GUI, where you can write and test your API. And so here I have like 11 movies and it's showing up there. And if I want to write some kind of a more expressive, complicated query, I have one copied here, for example, like this. So here we are again querying movies, which have a release date that's between 1998 and 2001. And having a published date, either published or not published, or having a title which includes the word metrics in a case insensitive search. So some example like that. If I run this, I get some output here because so all of these movies are between the state range and metrics. Even though maybe I can remove this because that's the only one with published. If I remove that and still run it, I would still see it. So because here I have like a or condition going on. Basically, I'm filtering out if it's either not published, which the other ones are, or if it has a title metrics in the query. So, and looking at the mutation side, I can go into mutation, press new, and you already have the CRUD stuff going on here. So these were the queries. And then here you have like create movie. I don't know, we are devs movie, intro. And then I can query the output back of that movie ID with publish status. So creating it, call that and done. So you can see how easy this is to create data and manipulate data without writing a single line of code for your resolver. So this is what I wanted to show very quickly. And so that's basically it. And conclusion, I would like to end with, it's a very common thing that building microservices is inherently difficult, but I would like to say that it's not the full truth. If you are using the right tools, then this is not that difficult for the correct context, right? And summarizing our philosophy is to use the database as an API, where we expose directly the database schema through our GraphQL API, and we focus heavily on auto-generation and having performance as the default option, where you don't have this n+1 problems, for example, and you have very performant APIs out of the box. So thank you listening for listening, and this is all I actually wanted to say. So I would like to open up for questions at this point in time, if we can make it.
So thank you for your talk, Ruwan. It was very interesting. We do have time for a couple of questions, maybe one or two that was in the chat. The first one is the difference between this and Microsoft Access.
I'm not sure if I got the question right, but maybe in PostGraphile, what we are doing is something where we generate the API based on the schema. Okay, maybe yes. So in Access also you can have some database management system, and you can develop on that database. It's not really a production ready database management system where you have hundreds of thousands of records that you can insert, update, delete with very high concurrency, but it is still possible that you run a DBMS there. But PostGraphile, on the other hand, it focuses more on GraphQL side. So you have the database that you have in PostgreSQL, and on top of that, we have PostGraphile, which wraps that Postgre database and exposes a GraphQL API. And here they also offer you tons of plugins and stuff where you can customize it very nicely. And actually, this is really production grade. You can run hundreds of thousands of transactions parallelly with very high concurrency. So this would be my answer to this.
Okay, and maybe one or two other quick question, and one that was upvoted a lot is pagination possible with PostGraphile?
Yes, yeah, good point. Very good question, because when you are building these front ends, it's very common, and in a very high load service or solution, you don't want to have your front end struggling with loading all of that data and then being very slow to scroll different pages. So having pagination in place is extremely important, and PostGraphile understands exactly these needs, I would say. So out of the box, you already get pagination built in. So in the API that I was showing, where I only focused on the filters, there is also just below that where you can do filtering, but based on your start. Basically, you have two forms. You can have cursor-based pagination, or you can just do like the top 10. You can take the top n and then start from a certain position. So this is a basic form, but it also offers you cursor-based pagination, where it actually keeps the open cursor, and you can fetch the next batch and the next batch, and it gives you that n number of rows. And that's quite efficient, and it handles the connection opening, connection closing for you, so you don't have database starvation. So it's quite nice how they have implemented this, and if you check out their documentation, you will exactly find what you are looking for. So yes, pagination is definitely a consideration they have addressed.
Okay, great. And maybe one last question before we let you go back to work and I'm back on diaper duty. Can you generate GraphQL from other database providers like MySQL, Microsoft SQL Server?
Yes. So in the PostGraphile instance, I would say no, because this one, it's tightly coupled with Postgres. But there are alternatives to this, right? So there are other libraries that go on tread in similar lines, where it really tries to treat the database as an API, like PostGraphile does. However, PostGraphile library, it's tightly coupled with PostgreSQL, but there is a reason for this, because when the GraphQL schema is introspected on the fly, it needs to have certain database metadata stored for it to reflect from. So PostgreSQL actually has a very nice metadata management system. So it can take the types out and it can create corresponding types to that. It can pass the view definitions, the function definitions, and create computed columns for your GraphQL schema. So it depends heavily on these features that are offered by PostgreSQL. And one thing I didn't touch is like user roles and authorization. So PostGraphile also has a nice feature where it allows you to do GraphQL API authorization and using Postgres's row level security, for example. So Postgres offers very handy, nice, strict row level security features that PostGraphile can hook into and use that to give your GraphQL APIs also the same level of security, and having that defense in depth where you have the GraphQL schema secured, and also your database will anyway have the row level security and it will be secured. So this library right now focuses on PostgreSQL, but there are other libraries out there that actually works against different databases like you described, like MySQL, Oracle, and even MongoDB. Yes.